Imagine looking up at the night sky to see beautiful ribbons of light and color twirling and shifting. This phenomenon is called the Aurora Borealis, or more commonly, the Northern Lights. Thanks to modern scientific advancements, we know it is more than just beautiful. It is actually the result of a violent explosion on the sun's surface. So, to understand how these lights are created, let's start 92 million miles away. The sun constantly ejects particles from its upper atmosphere, also known as the corona. Sometimes these particle ejections are small, but other times they're massive. During a coronal mass ejection, or CME, billions of tons of particles are hurled into space. These CMEs happen when twisted magnetic fields in the corona become so stressed that they suddenly have to realign themselves, and this releases a burst of particles and energy in the form of a solar flare. These particles race through space at incredible speeds. Some of the fastest CMEs can reach Earth in just 15 to 18 hours. When these particles reach Earth, they're sometimes captured by our planet's magnetic field at speeds of up to 45 million miles per hour, then funneled toward the North and South poles. As the charged particles from the sun collide with atoms and molecules in Earth's atmosphere, this causes those atoms to become excited or heat up. Each atom is like a tiny solar system, with its nucleus at the center, like the sun, and electrons orbiting it at different distances, like planets. When solar particles collide with an atom, the electrons get warmer and are bumped to higher energy levels, further from the nucleus. As an electron cools down and returns to its original spot, it releases that extra energy as a photon, or light. When this happens millions of times, an aurora is formed. Earth's magnetic field directs these collisions toward the north and south poles, creating auroras in both hemispheres' auroral ovals. These are rings around the Earth's poles where auroras tend to be formed. In the northern hemisphere, this light display is called the Aurora Borealis. In the southern hemisphere, it's known as the Aurora Australis. Auroras often appear as shimmering curtains, arcs, or spirals, shaped by the waves in Earth's magnetic field. The colors of the aurora come from different gases in the atmosphere. The most common color, green, is produced by oxygen, but this gas can also become red if it's extremely excited. Nitrogen also adds hues of violet, blue, and pink. Scientists measure the intensity of solar storms with a standard geomagnetic scale, or G scale, where G1 represents a weak storm and G5 is extremely strong. This determines how visible the aurora will be, as well as where people will need to be for the best view. Generally, G1 storms are the most common, and the resulting auroras can only be seen from high latitudes, like northern Canada, Sweden, or Norway. However, in May 2024, a rare G5 storm hit Earth and caused auroras to be visible as far south as Florida for the first time since 2003. If you're in an area where the aurora might be visible, what should you do? To catch a clear view, try to stay away from city lights and plan to look north between 9 p.m. and 3 a.m. However, viewing conditions depend on the strength of the sun's storm and how clear the sky is. If it's cloudy or rainy, you might have to wait for the next geomagnetic storm. And if you're hoping to capture photos of the aurora, using a tripod and a long exposure setting will help you get the sharpest, most vibrant shots. Now that you know the science behind the northern lights, this stunning view becomes even more impressive. Those twisting colors and shapes are the final step of a journey that started with an explosion on the sun, crossed millions of miles, and reached our skies. If you're ever lucky enough to witness them for yourself, make sure you take a moment to appreciate the beautiful scientific phenomenon that makes them possible.